Okay, guys, I'm gonna try and walk you through these guided notes on graphing quadratic equations. I just got a new um, rating thingy for this iPad, so we'll see how it goes. Okay, so you guys have graph quadratics before. You learned it in Algebra 1, you did it again in Algebra 2, so hopefully this is a nice review for you and maybe you remember all this stuff already. But let's just kind of walk through this. So we're going to graph quadratic functions in standard, vertex, and factored form. Okay, the graph of a quadratic function is called a parabola. There are three forms of the quadratic equation. So the first one here, this is standard. This one is called vertex form. And this last one is called intercept or factored form. Okay, so we usually start off with standard form. You guys probably remember a lot of this. If A is positive, the graph opens up like a cup. So your parabola will look like that. If A is negative, the graph opens down like a frown. Wah, wah. Okay, all quadratic equations have a vertex, which is the turning point of the graph. Quadratic graphs are symmetrical across the axis of symmetry, or AOS. Which runs through the vertex. These are not my notes, by the way. I found these and thought that they were really good, so I'm filling it out with you at the same time. All right, so in order to find your equation for the axis of symmetry, it runs through the vertex, remember. So if you're looking at a quadratic or a parabola, right? You're going to have the vertex at the very bottom or the very top. Okay, your axis of symmetry is going to be this line that runs right through it. So it's always going to be a vertical line that goes right through the vertex. So the equation for the axis of symmetry is just x equals whatever the x coordinate of your vertex is. So x equals x coordinate of vertex. Okay, so sorry, I'm sort of running out of room here. Okay, next bullet here says a quadratic function crosses the y-axis. I think they're looking for how many times. So if you have a parabola that's either a U that's right side up or upside down, how many times could it possibly cross the y-axis? Does it have to cross the y-axis? Could it cross multiple times? Well, if you think about it, it can only ever cross once if it truly is a parabola, right? And it's never going to cross more than once, and it has to cross the y-axis. Even if it's way far away from the y-axis, since these ends go on forever in both directions, no matter where you place this on the coordinate plane, eventually it's going to cross the y-axis. So it will cross the y-axis once. The y-intercept always has an x value of 0. For a parabola, the y-intercept will be the point 0, comma, it's actually whatever c is. If you're in, yep, so 0, comma c. So if you pop in a 0 for x, whatever c is, there's your y-intercept. Okay, so we were just talking about a quadratic crossing the y-axis. What about the x-axis? That's a little bit different, right? So if you think about it, we could have most of your quadratics are just going to form a parabola that, you know, just something like that. And how many times did that cross the x-axis? We've got 1, 2. Will it ever hit again? No, because those ends are going up and away forever. They'll never come back down. So we can certainly have 2 times that it's going to cross the x-axis. But that's not the only scenario. I could also have a unique case where the vertex is just, oh, I missed it just barely. Let's just make the dot kind of big. This is hard to write with these stylus things. But anyway, you could have that. This is usually what we refer to as a double root. So if you were to solve that quadratic, you would get the same number twice. But it really is only touching in that one spot. So that is a possibility to have one time where it crosses the x-axis or touches, right? And then there is a third case. If I had a parabola, say maybe one like this, that guy's never going to touch that x-axis. It's just going to keep going down forever. I mean, it could have been up here too. It doesn't matter. But I can have parabolas that don't ever touch the x-axis. So there you have it. Quadratics are either going to have 2, 1, or no x-intercepts. And remember that an x-intercept is really just what we call the solution to the quadratic. So when you solve a quadratic, if you have a quadratic equation, you solve it, those values are actually where the graph crosses the x-axis. So you're either going to get, well, I take that back. You're always going to get 2 answers. Sometimes it'll just be 2 numbers, and that'll be like our first case. Sometimes you'll get the same answer twice, so that would be a double root. And then in your third scenario, if it's never going to touch the x-axis, you're going to end up with an imaginary solution. Okay. Oh, let's see. I'm trying to figure out how to scroll up. I think I have to unclick that. Oh no. Oh, can I not scroll up? I can only scroll to the side. Okay. So let's do the bottom, and then I'll erase all this and scroll over. Okay, we're all still learning. We don't know what we're doing here. At least I don't. You guys probably know, but I don't. Okay, on the bottom, here's a graph. Oh, you know what? I was looking at this one before, and I think they're supposed to give you the equation to this, and I don't. All right, I guess we're just gonna guesstimate where these things are, which I don't love, but again, this is not my note sheet, so I'm not totally sure if they gave an equation or not. But the vertex of this graph, oh shoot, I gotta put it back on. Okay, there we go. There's my vertex, right? And if I had to guess, I'd say that's about at, oh gosh, 1, 4.5. 1, oh dear. What? I don't really know how to erase. I think the erase button, I'm gonna have to find it in a minute. 1, 4.5. I think it's hiding under this other, I have a screen in my way. Oh, wait, there we go. Okay. Axis of symmetry would just be the vertical line that runs right through this. So that would just be x equals 1. My y-intercept, again, I don't quite know. So I'm going to guesstimate that's about 3.5. So that would be at the point 0, 3.5. And my x-intercepts, again, I got to guesstimate here. Looks like I've got one at about negative 1.3 maybe. And another one at 3.2. Okay, so let's erase all of this if I could figure out how. Oh, how did I do this before? Oh, eraser. Yeah. There might be a faster way than this. I don't know. Remember, just learning. Okay, sorry, bear with me. Oh, and here comes my son. He's gonna want to touch this, I know it. I'm gonna have to stop this video and come back.
Help! Help! Help!
What, honey? What do you need, bud?
Help!
What do you need help with? Okay, let's try this now. So here we have an example of a graph in standard form. So first thing we want to do is figure out where the vertex is. So you might remember the formula for vertex. Oh, shoot. There we go. To find the x coordinate, you're just going to do negative b over 2a. And then whatever value that gets you, you're going to take that value back and plug it back in for x into the original function and see what comes out. And that'll get you your y coordinate. So to find the vertex, it's really a two-step process in standard form. Okay, so let's go ahead and find that x coordinate. So negative b over 2a, b is negative 8, so negative 8 is now going to be positive 8 over 2a would be positive 8. So 8 divided by 8 is 1. I don't know what this line was for. We don't need that. But anyway, so when I plug, do negative b over 2a, I get out a positive 1. Okay, so now we're going to take 1 and plug it back into the equation. So we're going to find f of 1.
Look, you found.
Oh, wow.
It's on my hand.
Go show daddy.
No.
Sorry, guys. All right, so let's plug in 1 and see what comes out. 1 squared is 1 times 4 is 4 minus 8, negative 4 plus 1, I get a negative 3. So there's my vertex. It's at the point 1 comma negative 3. Okay, so let's go ahead, and they have this box over here of key features. Let's go ahead and pop in what we need. So in my original, A was 4, B was negative 8, C is positive 1. We can tell before we even start graphing if this parabola is going to open up or down, and that's all based on the value of A. Remember that if A is positive, it's up. If A is negative, it's down. So this one has a positive 4, so it will open up. And okay, so for the max or min, if you don't remember, if your parabola opens up like a cup, oh yeah, we did talk about this, so you probably remember. So that would be a minimum, right, because it's the lowest point on the whole graph. If it opened down like a frown, it would have a maximum. So in our case, since this is opening up, we're going to be at a min. The axis of symmetry, remember, is just x equals whatever that number is. Okay, so it's x equals 1. You have to write the whole equation too. You have to write x equals 1. Oops, I didn't mean to. That's so important. If you just write 1, 1 is not the equation of a line. Oh, wow, go show daddy.
It was minis.
Oh, okay, go show daddy. Okay, so we have our axis of symmetry. We already knew our vertex was at 1 comma negative 3. The y-intercept, remember that's always going to be at 0 comma whatever c is. In this case, that's 1. And I don't know what they mean by point. Yeah, I have no idea what they're going for there, so I'm not even going to bother with that. Okay, but I do have enough to go ahead and start popping this in. So 1 negative 3.
So.
Okay.
So. I want to stand on it.
Stand on what?
This.
On my chair?
Yeah.
Okay, so 1 negative 3 is my vertex, and then I can go ahead and graph my other points. I know I have a y-intercept at 0, 1, and don't forget, oh, geez, why isn't this? 0, 1, there we go. Don't forget you have that axis of symmetry going through that vertex. So let's see if I can draw in an axis of symmetry here. Try this. Maybe that's a little too dark. But anyway, there's my axis of symmetry, and I can go ahead and mirror that point over. So I had the point at 0, 1. I can mirror it over to 2 comma 1. Okay, and now, I mean, I can plug in more points if I want. If you need more points, you can plug in x equals negative 1 or x equals positive 3, because they're going to get the same y values, right? Because they're going to be reflected over that axis of symmetry. So if I just plug in a negative 1 real quick, that's going to get me, Oh, let's see, that'd be a 4 plus 8 plus 1. So I'm way off my chart, so I'm somewhere way up here. Okay, so let's make this parabola nice. And there we go. And there you have it. Okay, so if I were you, I would pause for a minute and then you do the bottom one. I'm just going to go through it real quick right now. There you go.
Thank you.
You're welcome. Okay, let's see. So for the bottom one, A is a -1/2, B is 2, C is -1. This parabola is going to open down because A is negative. So the parabola has a max. The axis is symmetry. I have to go ahead and find the vertex first. So -b over 2a would get me -2 over -1. So that'd be a +2 comma something. So now take 2 and plug it back in. So let's see. Oh dear.
That's okay.
Yeah, that's okay. Or -2 plus 4 minus 1. So 1. Okay, so my vertex is at 2, 1. That means the axis of symmetry is at x equals 2. Remember, you need the whole thing, x equals 2. The y-intercept in this case will be at 0, -1. And I don't know what they want per point. Okay, so let's go ahead and graph it. 2, 1. And then a y-intercept at 0, -1.
I can use this one.
And I can mirror that over. Okay. There we go. All right, let's try the next type. Okay, I figured out that I can pause the video in between. So now we're looking at vertex form. Oh boy. Sorry, I don't know if you can hear my kid. The squirrels are eating our bird seed and he gets very upset because he wants. I know, honey. Can you go show Daddy that thing that you found? Okay, so anyway, vertex form. Vertex form is so nice for graphing because you know where the vertex is. You don't have to do any computation. It's always just at whatever. Oh, here we go. H, comma, K.
Mommy,
What, baby?
it's my name.
Go show Daddy.
No.
Oh. Okay. So, and remember, whatever you see in there with the H, we always do the opposite of. Remember that? Okay. So, H, remember to take the opposite of the sign that's in there. All right. So, if you look at number 1, if I'm going to find the vertex of this thing, I want the opposite of that, comma, that. So, that means my vertex is at 2, comma 4. The value of A is just whatever number is out here. So, the value of A is just 2.
Okay.
Okay, honey. All right. Number 2, my vertex is going to be at -3, -5. A in this case would be a -4. And for 3, the vertex is at +1, -2. A is -1 in that case. So if there's nothing in front of that parenthesis, just remember that A would be a +1. Okay, so let's look at the example they want us to do. Oh, Miller, what are you doing? Okay, hold on. Jay, I'm trying to make a video and he's like all up in my business here. Honey, can you go see Daddy, please? Buddy, you gotta go see Daddy. Oh my goodness. Okay. All right. So anyway, we're looking at the example. A is equal to 2. This parabola is going to open up. So therefore it's going to have a min. Okay, the axis of symmetry. This is nice because remember, I can look at this and I know what the vertex is. It's just going to be the opposite of that number, comma that number. So my vertex is at 3, -4. So that means that my axis of symmetry is just going to be at x equals 3.
Daddy.
So the y-intercept, it's not quite as intuitive as it was in standard form.
Daddy. Daddy.
Miller, can you please? You got to go with Daddy.
I'm trying not to talk because you're
Well,
doing your videos.
yeah, well, it's all I'm in here already, and I'm not going to redo it.
Daddy. Daddy.
Come on, buddy.
Daddy.
Yeah, buddy.
I found my coins.
Okay, let's bring them to the living room.
Okay. Hey, Daddy.
We gotta leave mommy to work, okay?
Okay. I'm sorry. He hid the mouse, so I don't even know how to pause it now. So, oh my goodness, you guys, just fast forward through all that. All right, so y-intercept. You don't have, it's not as intuitive with the standard form because I don't have a c here, right? So, but I'm going to find it basically the same way. I'm just plugging in 0 for x and I'm going to see what comes out. So let's see, if I plug in 0 for x into that example, I'm going to get -3 squared, which is 9, times 2 is going to be 18 minus 4. So I'll get 14. So 0, 14. And point, yep, don't know what you're talking about. I don't know, point, they just want you to pick a number and plug it in. I don't know. Okay, so I have my vertex is at 3, -4. Okay. And the y-intercept is way too far off my grid. But what I can do, remember that there is a pattern with A. So when A is 1, remember when you're graphing quadratics, you can just go up 1, up 3, up 5. So now that A is 2, remember we just double all those values. So instead of going up 1, up 3, up 5, I can go up 2 over 1. Mirror that over to the other side. Remember, let me just sketch in my axis of symmetry. So I have that, so I went up 2 over 1, and then you would normally go up 3 over 1, but I need to go up 6. Oops. Oh dear, okay. So let's go up 6 over 1. Oh, come on. No, what? No. There we go. Okay, sorry. Up 6 over 1. And again, you can get these points by just plugging the numbers in directly. You can take 1 and plug it in to the function and see what comes out. But knowing the pattern just saves you so much time. So connect these with a nice smooth curve. And there you have it. Okay, so pause this and then you do the you try one. And when you're done, come back and see if you did it the same way I did. So on the bottom, A is going to be a -1. This parabola will open down. So it's going to have a max. So the vertex would be at -5, 2, which means the axis of symmetry is at x equals -5. Y-intercept, I have to do the math. Let's plug in 0. Oh, that's -25 plus 2 is a -23 when x is 0. And we don't know what you're talking about. Okay, so vertex -5, 2. And then if I'm going to use the pattern, since A is -1, I'm just going to take that 135 and multiply them all by -1. So instead of going up 1 over 1, I go down 1 over 1. Reflect that over the axis of symmetry. Now I'm going to go down 3. 1, 2, 3 over 1. And reflect that one over. There's my graph. Oops. Perfect. Okay. Now we're going to move away from vertex form and try intercept form. So let me just erase all these. Oh, I hope everybody's doing okay. Things are interesting at my house, to say the least, but we are all healthy, thank goodness. And we have all the necessities we need. Just trying to make everything work, right? Very unique circumstances we're in. Okay, that looks good. Let's scroll to the next page. Okay, factored form or intercept form. So to get in this form, first of all, you're just going to take your quadratic and factor it. Okay, so and then once you have factored it as far as you can, you are now in factored form. What those values get you, P and Q, notice they're both in there with the X, so we want to take the opposite sign of both of them. That's going to tell you where this thing is crossing the X-axis. A tells me everything that it always has, tells me up or down. It also tells me if it's going to be wide or narrow. So let's see, P and Q are the, I guess they want x-intercepts right here. P and Q are the x-intercepts, also called the zeros. Okay, so to find the axis of symmetry this time, because I don't know where my vertex is, right? The easiest way is to just add P and Q together and divide it by 2. So that's going to get you that x-coordinate of the vertex, which is your equation for the axis of symmetry, right? So pretty cool. So let's take a look at the first one. They already have it factored out for you. That means that and that are going to be my 2 x-intercepts. So they're going to happen at +1, 0 and -2, 0. Because remember, I'm taking the opposite of both of those. So to find my axis of symmetry, I'm going to add them together, divide by 2. And it's always got to be at x equals. You have to have the x equals part, otherwise it's not the equation of a line. Okay, so let's add them together. 1 and -2 together is -1. Divided by 2 is a -1/2. Okay, let's try number 2. The x-intercepts would be at -3, 0 and at -3, 0. So this is one that has a double root. It's only going to touch the x-axis at -3, and that's it. So the axis of symmetry has to just be x equals -3. All right, and then number 3, let's see. They'd be at 7, 0 and -1, 0. Axis of symmetry, 7 plus -1 is 6 over 2 is 3. So x equals 3. Okay, so let's try the first one down here. A is -2. This parabola will open down because A is negative. The axis of symmetry, I don't know yet, and the vertex, I don't know yet, but I do know the x-intercepts. I'll come back and fill in the other 2. The x-intercepts are going to be at 3, 0 and at 2, 0. Okay, so now I can figure out where the axis of symmetry is. So let's add 3 and 2 together. I get 5 divided by 2 is 2.5. Okay, so to find my vertex, I know it's going to be at 2.5, something. I'm just going to have to take the 2.5 and plug it back into my original equation and see what comes out. All right, so let's see. If I plug 2.5 in up at the top here, that's going to get me -2 times, oops, I touched something. Okay, so 2.5 minus 3 is going to be at -0.5. And then a 2.5 minus 2 is going to get me a +0.5. So let's see, what would that be? +1, +1/2. Okay, so let's plot everything. Oh, y-intercepts, let's see, I can do that. Again, this one's not super intuitive. I can't just look at it. I have to do a little bit of math. So let's plug in 0 for x and see what our y-intercept would be. So that's going to be, I'll just do my work over here. -2 times -3 times -2. So -12. Okay. All right, so let's graph what we have. I know it's crossing the x-axis at +3 and at +2. Pretty close to each other. The vertex is at 2.5, 1/2. So, oh gosh, that's really hard to get with this stylus. Well, it's too high. That's the best I can do, guys. All right, let's see. The y-intercept is way off. And since my vertex isn't at a great spot, it's kind of hard for me to apply my pattern. You can, but it's a little bit trickier. I would advise, why not just plug in +1 real quick and see what comes out. So -2 times -2 times -1. That's going to be -4. So at 1, I know I have a point at -4. Mirror that over. 1.5, 1.5 right there. Okay, and there's my graph. Okay, so pause it and then you do the bottom one and we'll see how we do. All right, in this case, A is just 1 because there's nothing in front of there. So it's going to open up. I'm going to jump down to the x-intercepts, which are going to happen at -1, 0, and at +4, 0. Okay, so my vertex, I'm going to add those two together, divide by 2. So that gets me 3.5. Take 3.5 and plug it back in, and we'll see what the y value is. So it's going to be at 3.5 comma something. So that'll be 4.5 times -0.5. So what's that? -2.25. Okay, y-intercept. So let's plug in 0 for x. That's just going to be a 1 times -4. So -4. Okay, so let's plot everything that we have. X-intercepts, one of them's at -1, one of them is at +4. The vertex is at 3, and oh, that vertex is not right. What did I mess up? Oh, 3/2 is 1.5. Oh, geez, Louise. So that's all wrong. Let's plug 1.5 in, silly goose. So that's 2.5 times 1.5 minus 4 is 2.5 negative. So that's a -6.25. Sorry. Okay, that makes more sense. So 1.5 -6.25, right about there. Okay, I have enough to, I can pop in that y-intercept, mirror that over. Be right there. Okay, looks good. Okay. Not bad, not bad. All right, I don't know if there's another page. So let me erase all this. While I'm erasing this, I'll tell you a fun story. My son learned his first swear word. It's been very interesting in my house. Oh my goodness. So if you hear anything, I apologize. Okay. Oh, that's it. All right. So I hope this is helpful. My goodness, I hope this recorded. If it didn't, I'll be so sad. Even though it was kind of a bit of a train wreck, but it is what it is, guys. All right, hang in there. See it? Oh, I don't even know where the mouse is, so I don't even know if I can pause this. Stop this video. Oh my goodness. Well, you can listen to me look for the mouse for a few minutes. I found it.